Question 2. A long straight wire carries a current of 5 ampere upward. At what distance from the wire is the magnetic field due to the current in the wire to be equal in magnitude to the strength of Earth's magnetic field? Okay, so this is on long straight wire. So remember the formula for long straight wire is mu naught I over 2 pi r. This is to calculate the magnetic flux lah. Okay, so I is given as 5 ampere and magnetic flux is given as 5 times 10 negative 5 Tesla. Okay, so from here we are just gonna substitute into the equation to find the value of R. So rearrange and calculate them. You should get the value of 0.02 meter. Okay, now question B pula. It asks us to two long straight parallel wires are 20 centimeter apart. So there's two wires, it should be the same lah. Okay, so they are parallel wires 20 centimeter apart. So this is 20 centimeter. Okay, so each carries a current of 10 ampere. So dua-dua bawa current a value of 10 ampere. Okay, so find the magnitude and direction of the magnetic field at a point midway between the wires if the current are in the same direction and the other one in opposite direction. Okay, so that is similar to our example in the notes. So this time the current is in the same direction. So this is I, this is also I. Okay, so remember we have to use the equation of magnetic flux. Again, for wire is this equation lah. So calculate that, you should get 2 times 10 negative 5 Tesla lah. Right, so if both wires produce the same magnetic field, remember untuk current pointing in the same direction, dia punya magnetic flux would be pointing up and down. Okay, so dorang in different direction lah. Okay, but since they have the same magnitude, which is this value here, so remember, let me just label it as B1 and B2. This is 1, this is wire 2. Okay, so since they have the same value, if you are gonna add this together, this one's gonna be negative, it would gives us 0. Okay, boleh faham ke? Kita dapat 0 lah, sebab the resultant magnetic flux would be negative B1 plus B2. So since this is the same value, it would gives us 0 lah. Okay, now untuk question apa ni? In the opposite direction pula. So now the wire is in the opposite direction. The current would be in the opposite direction. So untuk yang ini, the magnetic flux pula would be pointing in the same direction. Okay, so this is B1, this is B2. Hence, the resultant does not equal to 0. Okay, so the resultant magnetic field is just the addition of these two values. So B is equal to B1 plus B2. Since both are pointing upwards, it would be negative 4 times 10 to the power of 5, negative 5 Tesla. So the direction is upwards lah. So because sebab dia tunjuk negative. Okay, so boleh faham? That is for Roman 2. Okay, so I guess that is for question number 2.